you can see that we're going to find all the zeros. The rational, obviously the rational, the real, and also the imaginary as well. And we'll go up here and take a look at this. But before we do, let me go back to the last problem. And here's the graph of where it's kissing the x-axis. You notice that -4 happens twice, so there's a kiss right there. So find all the zeros of this x to the 5th. So we know there's going to be 5 zeros. Okay? And it turns out that when we factor it out, we can see that this is a couple, and this is 1. And then we can't factor this other one, okay? We try. Looks like maybe we could, but we can't. And we have to rely on the quadratic formula, which they just kind of, they say, well, use the quadratic formula. They don't show us how they did that, but we can do it with the quadratic formula, and we will. So we have 3 real roots, 1, 2, 3. One of them gets repeated twice, so in my book that's a kiss. And then 2 are imaginary, okay? So they say, oh, it's tangent to the x-axis. Okay, fine, tangent, kiss, whatever. And oh wait, I was marking that as imaginary, but it's not. That's also real. I can't mark the imaginary roots, right? Because they don't cross the x-axis. They're zeros or roots, but I can't mark those because they're imaginary. If I could mark them, I guess they wouldn't be imaginary. But just think about this. If my factor is raised to an odd power, like, let's see here, x to the -2, that's raised to an odd factor, right? Normally, we have factors that are raised to 1. Well, 1 is odd. If it was x to the 3rd, that'd be odd too. But anyway, if it's raised to an odd factor, then it crosses the x-axis at that value. Okay, that's what I'm highlighting over here at the graph. Well, wait, that's not crossing there. Here it's crossing. Okay, and then if it's even, like this 2 right there, you see that 2? Then they say it's tangent to the x-axis, and they're talking about right there. Okay, where it's tangent, or like I say, it kisses the x-axis, okay? All right, so however you look at that, that's great. So if it's even, x to the 4th, in our cases so far, x squared. Let's look down here and see what we get. Find all the zeros. Well, there's a 6 out here, and there's a 1 here. So also I have a nice sketch here, so it really looks like 1, and it really looks like -2. It really, really does. And oh, by the way, it looks like it's kissing right there. So let's see. Let's go ahead and do this. We will say, well, okay, my possible zeros. 1 plus or -1, plus or -2, plus or -3, plus or -6. Not worried about the bottom because it's 1. Okay, I'm just worried about this number out here, the constant. And I know that I'm going to try 1. I sure am going to try 1. So I get 1 and -2 and so forth like that. -2, they skipped. Oh, look, they skipped x to the 3rd. They skipped it. Okay, so I'm going to put a 0. So I put a 0 for x to the 3rd, and then 8 for x squared, and -13, and 6, and let's see what we get. Hopefully we get 0. So we bring down the 1, and 1 times 1 is 1, plus -2 is -1, 1 times -1 is -1, plus 0 is -1, 1 times -1 is -1, plus 8 is 7, 7 times 1 is 7, plus -13 is -6, times 1 is -6, added to 6 is 0. Okay, And by the way, I know this happens twice because I have this graph, so I'm just going to use it again. Okay? You say, is that legal? Well, sure. So I have the 1 comes down, and 1 times 1 is 1. 1 plus negative 1 is 0. 1 times 0 is 0. Negative 1 plus 0 is negative 1. 1 times negative 1 is negative 1. 7 plus negative 1 is 6. 1 times 6 is 6. Negative 6 and 6 is 0. Okay, so far, let's see. So far I have x minus 1 and x minus 1. And I have these guys left over down here. So I've done it twice. I need to do it one more time, because if I did it twice, it went down to x to the 4th, x to the 3rd. But I can't do anything until I get down to x squared. So what was one of the other choices I had? Negative 2. Negative 2 is another choice. Okay, so let's keep going. Negative 2. So we'll say negative 2, we hope. And we'll just write these again. 1, that doesn't look very good. 1, 0, negative 1, 6. I never start over. Some of you are going to go back to the original numbers. Don't do that. Why would you do that? We want it to be more and more simplified. So let's see. We bring down the 1 times negative 2 is negative 2. Negative 2 plus 0 is negative 2. Negative 2 plus negative 2 is positive 4. Negative 1 and positive 4 is negative 3. No, it's not. It's a positive 3. Negative 2 times negative 3 is a negative 6. Plus a positive 6 is 0. Okay, so that confirms that I also have x plus 2, because a negative 2 goes with that. And what's left over then? Well, let's see. I'm kind of running out of room. So x minus 1, I'm going to say squared, because it happens twice, right? And x plus 2, okay. And then, let's see, I have x squared minus 2x plus 3. And it seems like I could factor that. But as we look at the graph, we know there are no more zeros. So if I can factor that, either the graph is wrong or my work is wrong. But anyway, I can't factor that. And I'm going to use the quadratic formula. So let's see, a is equal to 1. B is equal to negative 2, and C is equal to 3. So I'm going to say x is equal to negative b, so that's plus 2, plus or minus the square root of b squared, which is 4, minus 4a, which is 1, c, which is 3, all over 2a, which is 1. Okay. So then I get 2 plus or minus the square root of 4 minus 12. I'm not surprised that my discriminant's going to be negative. If it wouldn't be imaginary if it weren't. So I don't know if that's a very good way to say that, but so we will say 2 plus or minus the square root of 8, negative 8, over 2. So let's see, the square root of negative 8. The square root of negative 8, that's 2 times 2 times 2, right? Underneath there, and it's negative, by the way. 2 of those 2's will come out. Okay, so I can say 2 plus or minus 2 square root. One of the 2's has to stay inside, and oh yeah, it's a negative. And there's a 2 on the bottom. Okay, so now the 2 on the bottom is going to cancel. Okay, cancels, cancels, cancels. As long as it has to cancel with both of these terms in the top, and it does. So I get 1 plus or minus the square root of 2, and instead of saying negative 2, I'm going to put an I out here. Okay, so now I can go ahead and finish factoring this, if I can remember that. 1 plus or minus the square root of 2. So I'm going to write the factoring down here. Oh, I didn't have to go that far up. I'm going to say x minus, I guess I'll put it in parentheses first, 1 plus the square root of 2i. And it's always x minus, right? X minus 1 minus square root of 2i, right? Alright, so if those are my roots, I always say x minus those roots. And now I'm going to just try to simplify this. Usually I go down, but this time I'm going to go up. I'm going to say x minus 1 squared, x plus 2. I have x minus 1 minus the square root of 2i. That's one of my factors. And then I also have x minus 1 plus the square root of 2i. Oh my. Alright, so there I am factored. I was just finding all the zeros. Okay, fine. So what are all the zeros? X is equal to 1. Twice. It happens twice. Because look, it happens twice. Okay, and also x is equal to negative 2 because of that. Okay. And then x is equal to 1 plus or minus. Instead of writing it twice, I'll just write it like this. Okay? Those are my factors of the polynomial. X is equal to, it said solve. Find all the zeros. Okay, those are the zeros. And as we count, we get 1, 2, 3, 4, 5, right? Okay, so there's 5, as there should be. Because why? Because I have x to the 5th, so I knew I had to have 5. This is what the fundamental theorem of algebra tells me. I expect 5, and I got 5. Maybe some of them are a little different. Maybe they're not all real, but I got 5.